Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Relentless presents a debate between Aaron Slodov and Sam D'Amico examining US-China manufacturing dynamics. Their analysis dissects how America has lost not merely production capacity, but the accumulated process knowledge required to manufacture at scale, treating factories as learning systems rather than execution facilities. The conversation reframes Apple's supply chain strategy, questions the viability of domestic hardware startups, and identifies regulatory structures that prohibit the physical chemistry necessary for advanced manufacturing. Aaron Slodov opens with a claim that redefines manufacturing itself. Factories function as reinforcement learning systems, not instruction, following mechanisms. The conventional understanding treats a factory as a facility that receives engineering specifications and executes them. Slodov argues this misses the fundamental nature of production. He draws a parallel to training neural networks, where a model requires millions of iterations to learn the correct parameters. A production line operates identically. The critical knowledge does not reside in CAD files or assembly manuals. It exists in millions of micro adjustments made during actual production runs: glue, temperature tolerances, conveyor belt speeds, humidity thresholds. These parameters are rarely documented because they emerge through trial and error on the line itself. Slodov's logic produces a stark implication. Manufacturing capability cannot be transferred by exporting blueprints. When the United States ceased high-volume production, it stopped generating the training data required to maintain these learned parameters. The nation did not simply offshore factories. It allowed the accumulated process knowledge to decay. Rebuilding that capability requires rerunning the millions of failed units that originally taught the system how to succeed, a process measured in decades rather than quarters. Sam D'Amico challenges a widely held belief about how Apple manages its supply chain. The standard narrative assumes Apple designs products in Cupertino, transmits digital files to China, and Foxconn executes the build according to specifications. D'Amico states this is false. Apple does not merely send files, it deploys entire engineering teams. His description reveals that the factory itself is the product being engineered. When Apple ramps a new iPhone, hundreds of engineers relocate to Shenzhen to supervise and adjust every process step in real time. They are tuning the production line as if calibrating a precision instrument. This inverts the traditional value distribution in manufacturing, where design captures high margins and assembly represents low-value labor. D'Amico's position is that without the ability to physically tune assembly processes on site, the design holds no practical value. Innovation occurs during production, not solely during the design phase. D'Amico introduces an analogy that reframes the Chinese manufacturing ecosystem. American hardware startups typically follow a prescribed path, prototype locally, avoid China until scaling due to intellectual property concerns or perceived quality risks. D'Amico argues this approach is structurally flawed. He describes the Chinese manufacturing infrastructure as functioning like cloud computing for physical goods. Consider AWS. A startup cannot afford to build its own data center, so it rents fractional access to world-class server infrastructure. D'Amico observes that Shenzhen operates identically for hardware. A startup lacks capital for $1 million injection molding machine, but in China, it can purchase a small fraction of that machine's capacity. The startup is not simply hiring low-cost labor, it is accessing a fractionalized engineering stack that includes supply chain logistics and co-design services. He offers a striking formulation. You can treat a Chinese factory like a large language model. You provide a rough concept, and it generates a complete supply chain and engineering solution. This suggests that the barrier to hardware innovation in the US is not purely financial, it is the absence of an efficient interface to access physical production infrastructure. D'Amico identifies a regulatory constraint that goes beyond cost considerations. The typical explanation for manufacturing decline blames environmental regulations for raising costs. D'Amico presents a more extreme claim. In regions like California, chemistry involving metals is effectively prohibited. He points to the modern electric stack batteries, power electronics, advanced coatings, which requires chemical reactions with metals. Due to regulatory frameworks accumulated over 50 years, the fundamental physical processes needed to produce batteries or coat circuit boards are zoned out of existence in America's primary innovation hubs. The issue is not expense. The processes themselves are legally banned. This creates a paradox where Silicon Valley, home to the world's leading engineers, cannot legally perform the physical chemistry required to build the products they design. D'Amico flags a strategic oversight in the current AI infrastructure build-out. The industry is fixated on semiconductor supply chains. D'Amico notes that AI data centers are massive electromechanical systems, batteries, cooling systems, power supplies, steel racks. These components are currently imported tariff-free. His assessment, the United States is missing its largest reindustrialization opportunity. While attention focuses on GPUs as the critical asset, the physical infrastructure surrounding them is being outsourced because it is classified as computing equipment rather than heavy industry. If the AI data center construction wave were treated as an industrial manufacturing project, it would provide the high volume production needed to rebuild domestic manufacturing expertise. Instead, that learning is occurring overseas. D'Amico offers a counterintuitive critique of the US defense sector. The common reassurance is that military spending drives innovation, ensuring American manufacturing remains viable. D'Amico argues the defense industry is degrading US manufacturing capability. His reasoning centers on production volume. Defense contracts typically involve fewer than 10,000 units. In a framework where manufacturing is reinforcement learning, 10,000 units provides insufficient data to develop robust process knowledge. Defense contractors excel at building expensive, low-volume prototypes, but this atrophies the skills required for mass production. This creates a structural contradiction. The companies tasked with securing national defense are institutionally incapable of the high-volume manufacturing necessary for modern industrial conflict. For hardware engineers or industrial policy strategists, D'Amico's recommendation is direct. Visit Shenzhen not to outsource production, but to observe a fully integrated hardware cloud in operation, understanding precisely what infrastructure needs reconstruction domestically. If you're interested in the video featured in this episode, click the link below to watch the original.